So I am Jimud Vahanpal and today I am going to talk about a project that is playing a class of games using CNN. So I am from the Department of Computer Science, Ramakrishna Mission Vivekananda Educational and Research Institute, and this is a presentation for a communicative English course. So I will be talking about the motivation behind this project. So this was my side project during second year of St. Xavier's College, and one day my friend Indranil told me about a cool way which we can use to make computers play games. It was second sem and we were all wanting to do some machine learning using the available tools. It was a buzzword back then, that is ML, DL, AI, machine learning, deep neural networks, convolutional neural networks, etc. And everybody wanted to know more about these stuffs. So I thought of giving it a try since it was very exciting at that moment. So left one is the picture of Indranil, my friend who told me about this new idea to make computers play game using CNN, that is convolutional neural networks. And right side is the picture of Harrison, who created the first version of an AI which can play the famous GTA 5 game. He have used several terabytes of data to train a CIFAR 10 model that actually gave some pretty good results. What he actually did was to make the protagonist drive and around GTA 5 city using machine learning model. The main structure of the AI system is to take a set of images for training data and record its corresponding action value. Train those images using standard model like CIFAR 10 in this case, and then use that trained model to predict the movements by recording frame in real time. So what is a CNN? So CNN stands for convolutional neural network, and those are used for analyzing visual imagery and even in day-to-day life like face detection and recognizing image for postcards in general. So Jan LeCun was the one who invented it, and it was used for automating PIN code detection in postal offices. So he was the one who invented it before it was even existed. So when Alex Krivitsky built the first CNN model known as Deep Belief Network, after utilizing the GPU's power, machine learning became popular. Since now, humans were able to perform massive amounts of computation in a short period of time. Later came CIFAR 10 model, which gave 80% accuracy in 2010 on CIFAR 10 dataset. This is relatively simpler than GPipe and Beetle model, which are the state-of-the-art for today's date. And here CIFAR 10 model stands for Canadian Institute for Advanced Research. So CIFAR 10 model actually gave 80% accuracy in 2010 on CIFAR 10 dataset. So our motive was simple: whether we can make something innovative using simple technology. Can we just look at static images to predict the next move? This is famous CIFAR 10 model as shown in this figure. So it takes an input. There is layer 1 convolution, then pooling layer, convolution layer 2, then pooling layer, then convolution layer 3, and pooling layer, and then fully connected layer and software layer. So this is a deep neural network architecture, and here where the prediction takes place. So this is the famous CIFAR 10 model which we will use for training. Now we selected a wrong game. So the first game that came to our mind for testing is the classic Pong game. It is a simple table tennis game from 1972 Atari console. Here is the picture of the relic, as you can see. So we used a simple version using some coding in JS. So we thought of making a very simple version which will take only this part of the screen for training the dataset. So now comes the data collection, the most boring part of any machine learning for a machine learning scientist. So we used OpenCV as our tool to capture images while we played, and here is a picture of the dataset. 0 is for down action and 1 is for up action. So for example, when we pressed down arrow key, it will capture a cropped snapshot of the instance of the game, and it will store the corresponding 0 value, that is action value, into the action.csv file. Instance of the data is shown here in the figure. Now comes the training. So firstly, I don't have a GPU in my house, so I took it to cloud, that is Google Drive, and used Google Colab for training. It is a free service given by Google. It is very useful since it has got GPU to fast of computations. This is an instance of the Google Collaboratory platform. A rather annoying thing I would say about this Google Collaboratory is if you don't perform any action, keep the computer untouched for about 25 minutes, then the browser gets disconnected and all the progress will be lost. So one solution is to save the checkpoints of the Python notebook. When it gets disconnected, the script will again start running from the path after which it got disconnected. Another solution is this figure, that you can use the simple JS script to keep the connection alive by automatically clicking the button after every 60 seconds. So this is the JS script. It will automatically keep the click the button and keep the connection alive. So this hack is quite useful when you are training for about 5 hours, but the max limit is about 13 hours. Then Google will block you temporarily. If you know a little bit of JS, then open your console using developer toolbar. From there, paste this code and then you can work as needed. So it won't allow pasting at first, so you have to check this allow pasting, and then it will do your job. So then here comes the picture of the loss and accuracy of the Pong game when trained with 2K images. So here we can see that it is performing about 90% on the train set and 85% on the test set. So it is quite well, right? 90% of the time it is predicting correctly. But when we played, we saw that it is not even performing 50%. It is not even performing randomly. It is if we take like 50% chance toss of a coin, like random, so it is doing worse than that. So then we thought, what can go wrong? So we used a simple thing that when we increase the data, we should get good accuracy. So we increase the data, and this is for 30K images, and we can see that the trend set is like very good, but the test set, we can see it is giving about 52% accuracy. That is also fluctuating. So this is a very simple case of overfitting, common case of overfitting. So what is wrong? We thought to ourselves that what is wrong, this shouldn't happen. Like for a standard model, like state-of-the-art model, which is finely tuned, but it is not still working as expected. We thought about it a little bit, then said ourselves why it might be wrong. So we thought of the static images of this Pong, and so firstly let's talk about this image. The left one is a CPU. So what does the CPU do? It is just a robot, that is, it computes the value of its movement according to this ball. So if the ball goes up, this will go up, and there will be some like alpha constant into which it can perform the computation. Like if the ball is very fast, then it will not go fast. So in that case, if the ball is fast and it is going fast, so it is never like you can never win this. So for that reason, some amount of constant is there. So if the ball goes fast, this will gradually go up to its speed limit, but this is just the robot, this is not AI. But in this case, for this right side, this is our AI, so we needed a human touch. So what can human touch do is it can increase the speed, unlike this robot which performs a constant amount of computation and constant amount of speed. But this the AI may click it like 5 times in a second, so it will move faster than this robot, so it can perform quite well for this game. So In recent, not recent, it's like 2016, we have seen that DeepMind performed a performed several experiments on the Atari console games, and it performed better than humans. So think of this picture. So from this static image we can see that if the ball is going this side towards the paddle, then the paddle have to move down to bounce this ball up. But if this ball is going in this side, then the paddle need not bounce or perform any computation. So from this we can infer that by looking at a static image we cannot really determine the position of the paddle, of movement of the prediction of the paddle. So this is the reason why Pong fell. So so we by looking at the Pong's picture, a human itself cannot tell whether the paddle would move up or right, so it is harder for the computer to tell. So for that we can use something like RNN, LSTM, or advanced model, which can store the previous state of the game, and according to that it will perform. So we will think of making those in the near future if time permits. So we thought, is this the end? Can we not play games by using only static images? The answer was that there exists a class of games which can actually give good results. They are called runner games. They have only a definite move for every instance of the game. So this is the picture of the famous dino game. It can remain stationary or have to jump. So by feeding the DNN with a lot of images, it will find a pattern that more the closer this dino is from this cactus, the higher the chance for dino to jump. So it can find this pattern by itself. So the same goes for this Flappy Bird game. And one disgusting thing about this Flappy Bird game is it is very hard to play. So for a CNN it needs at least 1000 images on a simple model, and so this is very hard to collect the data. My highest score is, guess what, it is 6, and so this is not possible for me to collect the data for Flappy Bird. So but in theory this can be played, and it can also play Asphalt, this overdrive game. You just need to go left or right depending on the situation. Even Temple Run can be played, but with a very low reflex time. So theoretically it can be played, but I'm not sure whether such hardware exists or not, because it is very hard for the computer to perform real-time operations computation on such low reflex time. So yeah, so it cannot even play this Road Rash, a nostalgic game, because it is more likely like this Asphalt Overdrive game. And we also made a custom balancer game, which will we have to balance this against the gravity. So it will randomly fall this side or that side, and if it falls this side we have to press the right arrow key to balance it, to move it left side, and if it overbalances then it will fall right side, and we will again have to press this right arrow key to move it to right side, and this will fall continuously and it have to get balance every time. So this can also be learned. So the balancing of needle can be done in theory by the CNN. So this is the data collected for Dino game. It is same as that Pong game. So the frame corresponding action values. So 0 is for nothing and 1 is for up. So here only one action is two actions are performing, that is 0 for nothing and 1 for up. So this is the result for Dino game. So results obtained are satisfactory. It performed well and runs genuinely with 90% accuracy. That is, when we tried in our laptop, we saw that it actually gave about 90% time the correct results, correct jumping states. From this result, we can conclude that certain class of games perform well with just a simple technology like CNN. So this is the accuracy and this is the loss of the dino game. So in conclusion, modern technologies and algorithms like recurrent neural network, reinforcement learning, genetic algorithms are more powerful than method that was implemented. We will implement this in dino game in the near future. The yellow works on this exact same model, that is extracts frame from video and predict those taken pictures. So yellow is actually a complex part of this CNN where it will localize the predicted things, but yeah, this is the basic of all the other architectures. So acknowledgements: I acknowledge the help received from Tamal Maharaj, Professor Janardhan Ghosh, Indranil Das and Harrison Skins, left out their suggestions and discussion. These are the reference, and thank you.